Alright, so my name's Jeremy. I'm with Energy Wise, obviously, and I'm going to try and give you guys a few basics on the theory of air conditioning, heat transfer, how it works, and maybe help you guys kind of understand the basic knowledge of air conditioning and how you can apply it to phone calls if you get them and questions as they come. One of the most important things to understand about air conditioning or refrigeration is what we call it in the industry, is heat transfer and the theory of heat transfer. And a lot of people will say, I'm going to cool off the space. And you're not necessarily cooling off the space, you're displacing heat or energy. As you guys know, the only new energy that we receive on the earth is from the sun. That's in the form of heat. So everything we do from that point on is just moving or transforming or displacing heat or energy. Okay? If you just take a basic house, for instance, say it's a 1,200 square foot home. A 1,200 square foot home is just a thermal mass that's going to absorb energy or heat or sunlight. As that thermal mass or that house absorbs that heat, it's going to absorb a certain amount of BTUs of heat. Now BTU stands for British Thermal Unit, and it's something that you guys are going to use quite frequently as you're talking to customers and dealing with clientele. It's just a abbreviation for describing heat or the amount of heat that's in a specific volume or area. So if you take a 1,200 square foot home, for instance, I would say that a 1,200 square foot home roughly should have about 3 tons of air conditioning. Now, the word tons of air conditioning is something that's described in the heating and air conditioning industry quite a bit. The best way for me to describe what tons is in BTUs is 12,000 BTUs per hour. Okay, that's actually 288,000 BTUs in a 24-hour period. And the person that come up with that is essentially a guy that took a 1-ton block of ice and he applied a certain amount of BTUs of heat to that 1-ton block of ice, and that 1-ton block of ice melted in a 24-hour period or absorbed 288,000 BTUs of heat. So if you take that 288,000 BTUs of heat and divide that by 24, you come up with 12,000 BTUs of heat. So this house is essentially capable of absorbing 36,000 BTUs of heat an hour. So for us to displace the heat that this house is absorbing from the sun, we have to have the ability to remove 36,000 BTUs of heat per hour. Okay, so if you guys take our initial model that we're going to probably hit the streets with, it's 12,000 BTUs, which is roughly a ton of cooling. So if you take and put a unit in a 1,200 square foot home and expect it to take care of the whole 1,200 square feet, if you do the calculations that I've just given you, it's not going to do the job. It's just going to run and run and run, cost a lot of energy, and eventually have some sort of a mechanical failure, and eventually give out and probably not work, and you're going to get a complaint. So as you guys talk to customers and deal with customers, you need to make them understand that a 12,000 BTU unit or a 1-ton unit is it's sized roughly for a 400 to 600 square foot room. Okay, the windows all have to be shut, because if the window is open, we're going to be absorbing additional energy from the sun. So if you've got the window open, you're not keeping up with the thermal mass, you're keeping up with the thermal mass and the outdoors. So with that said, some of the other things that you're going to want to understand or ask the customers as they call with complaints or concerns about the size of their unit is if they was to take a 400 square foot room, say you divided that, and in that room it had a refrigerator, maybe an oven, soda machine, those types of things. those are all things that are going to add additional heat to the space. Additional heat that this unit has to displace or remove from the cooling atmosphere. So if they have those things in that room, it's going to affect the performance of the unit, and it's going to affect how it works. Those are things to ask. Something else that's extremely important with air conditioning is airflow. And it'll probably be your biggest concern when you're talking to customers about airflow, is there's a little filter, a washable, removable filter that goes on the unit. And I would say that filter should be cleaned once a month. If that filter gets dirty, the air conditioning unit is not going to work properly. It has to have X amount of airflow with X amount of BTUs to transfer the energy from point A to point B. If it does not have that airflow, the unit's either going to freeze up, it's going to build up with condensation, or it's going to fail in some way, shape, or form. Could even trip a breaker, could damage an outlet that it's plugged into. It's just hard to say how that's really going to affect, but it definitely needs to have good, clean airflow. With that said, you can't push the unit right tight up against the wall either. You know, it's got to be out. It has to have a good amount of airflow all the way around it. You can't have it stuffed in next to a couch, stuffed into a corner. And again, you can't have it something in front of the airflow coming out from the unit. Just to give you guys kind of a general rule of thumb, just an industry standard, is about 400 square foot per ton, okay? Now that'll vary depending on altitude. Altitude is a huge factor when you're talking about airflow, and I told you guys the airflow is extremely important. If you've got a unit that's in, say, Missouri, okay, Missouri's going to have a huge amount of condensate in the air, or humidity, relative humidity. So there's factors to think about there. If they take the same unit and transport it to, say, like Steamboat Springs in Colorado, you've gone to a really high elevation. The air is much less dense. You're not going to get the same performance that you get at a sea level location. Most pieces of equipment are manufactured and distributed from a sea level location, and their performance data is most of the time written from a sea level location. So I would dare say that you could suffer a 1 to 200 square foot cooling loss depending on your altitude from point A to point B. So it's definitely something to think about, and ask that question when they call us, what is your altitude? Just to kind of give you guys maybe a little bit of an understanding about the theory of heat transfer and how it all incorporates into this unit and how it works. Each air conditioning system or refrigeration system, there's different types of air conditioning systems. You got evaporative type and refrigeration. This one is actually a true refrigeration unit, which falls under the category of displacing heat like we've talked about. The unit that we're selling has a compressor in it. It's most likely a reciprocating compressor. Some of them can be a scroll compressor. It's nothing more than a pump or an engine that's going to move refrigerant from point A to point B. A compressor is going to move the refrigerant throughout the system, and you're going to have what's called a condenser, and you're going to have an evaporator. And this really pertains to any refrigeration system, big or small, a walk-in cooler, a refrigerator, a drinking fountain, or our type of air conditioning unit. A compressor is going to have a refrigerant in it, most likely probably an R22, which is an HCFC or a hydrogen chlorine fluorine carbon mixture, which is environmentally friendly. It could also have an R410A in it, which is a hydrogen fluorine carbon mixture, which has no chlorine in it and would be even more environmentally friendly. It's going to run out of the compressor as a high pressure hot gas, go through the condenser, and at this point it's going to do what we call desuperheat. It's going to change state, condense, subcool, change state once again, absorb heat, superheat, go back through the compressor as a low pressure vapor. Leaks out of that nano mist tubing. It's going to